Hello, everyone. Just give people a second to get ready. Welcome to this year's Python Discord CodeJump Qualifier live stream. I'm Scalios, and if you're today, we're going to be going over our solution for the qualifier. Now, if you're not familiar with it, the CodeJam is an event that we host here at Bydis twice a year, summer and winter. During it, random people from all over the world sign up by solving a coding problem, the qualifier, which we are going to be solving, and they get paired up in random teams based on skill and experience. All the teams then are given a framework. In this year, it's TUIs, text user interfaces, and they are given a topic, a theme to work around and create a program based on. Beside the theme and the framework, you're allowed to do whatever you want. To give you an idea of what the theme might look like, last year's theme was early internet accompanied with the Django as the technology. This year isn't announced yet, but we're going to be announcing the themes tomorrow or Monday, and the jam's going to start on Friday, as well as a theme announcement. So let's first look at a few resources I've got prepared here. First, if you haven't seen it yet, this is our website, which has all the details about the CodeJam. If you haven't seen it, have a look at it. After that, the main thing we're going to be working on today is the qualifier. The qualifier is here. You should have seen this at some point if you signed up for the event. If you haven't, then what are you doing here? It contains the problem description, and it contains the template that you're going to be using to create your solution. So I'm going to switch over to my code editor now. We can go back to the qualifier. We can look at the qualifier documentation here, as well as the requirements. The first most important thing you're going to see here is that it's written in Python 3.9. It's going to be running in Python 3.9, and you aren't allowed to use any third-party libraries. There are a few more requirements here, but we're going to go over them later as we solve the qualifier. Now, for the actual description, the qualifier this year asks you to make a table to get yourself familiar with interacting with the terminals and get yourself familiar with Python functions such as print and print formatting. Now, we're going to come back to the requirements in a second, but first, there are some useful resources that I'd like to go over because they're going to come in handy for the stream. The first one of these is format specification mini language. Now, if this is on the Python.org documentation, most people probably have never seen this. And now, what this is just a few useful tools that you can use in print statements to format your code or format your prints. Now, if there's a lot of useful stuff here that you're going to find useful during the actual event as you use as you make your program. So I'm going to leave that linked in chat. I'm going to go over some of the simpler ones, some of the ones you might have seen, and the ones that we are going to need for today's solution. So that is not right. Now, this is just the template that you're given to start, but we're going to ignore all of that for now. Let's just look at some of the formatting tools you might have seen. First one is, if you've ever worked with numbers, you might have seen this format right here, which is simply printing to a certain decimal point. For example, we have the number 0.0123 here. Using this formatter, we can specify how many points after the decimal we want. If we were to run this, for example, you'd see the output here is 0.01 when the input was 0.123 because I used 0.1. Another one you might have seen is the percentage. The percentage does as it advertises. and it gives you the percent of something, the number as a percent. You can combine multiple of these specifiers. For example, we can join the decimal and the percentage specifier here, and we get 0.0123 as 1.2%. Now, for the ones that are going to be relevant for today, is they're mostly going to be related to alignment. If we go back to the documentation here really quick, we're going to be looking at these ones specifically: left aligned, right aligned, and center aligned. You can imagine how such things could be useful for making tables. But I prepared an example earlier. Here we just have some text that says hello. Hello is 5 characters wide, as you can count. And first things first, let's just look at what this does. Here I'm printing two pipes with separated by a space of 10 space characters. So if we just print that, we can see that it's just 2 pipes and 10 spaces between them. Now, if I wanted to center hello between them, I can look at the docs and see the centering here is the up arrow. If I try that on the code here, we can see that if I center this and tell it that I want to center it in a width of 10 characters, using the braces here, and print that between the 2 pipe characters, we can see how it centers them between how it centers them on the same level as the spaces. That way, we get both boundaries on the same level. We can also do the same thing with left align and right align to get the text to move to either edge of the boundaries. We can specify as many characters as we need. For example, a different number here would just be 13, and it does the same thing. Now, moving on to the actual solution. We're going to be sharing all of this solution code after the stream, but for now, this is the official solution. We're going to go over it piece by piece. We're going to build it from the ground up, just to give you an idea of what we're going to be working towards. So I'm going to switch back. Let's now jump back to the documentation and see what the instructions tell us. The first instruction here is the length of each row will always equal the length of the labels. So if you're given 2 labels, then you're going to have 2 columns. So each row is going to have 2 items. You're never going to have more or less items than labels. We're not going to have to deal with break line characters in any of the input, which is going to just be a helpful thing as we go along. And these 2 remaining items, we can just look at them in the examples because they're going to make more sense there. The first item there is, if an item cannot be centered evenly, the extra space can be placed on either side. So you can see how here everything was centered. So, and the longest option has 1 space before it and 1 space after it. All the options have 1 space before them, and then enough spaces to get the table to close up at the end. And the final rule here is just that it's basically what we just explained about the longest item is gonna have 1 space before it, 1 space after it, and there are a lot of examples here that are gonna be useful for making the program as we go along. The final thing to note is we're gonna be making the table from these characters. These are just the boundaries that go around the text. I have gone ahead and prepared them, all of them here in our qualifier document, so we can get right to coding. So let's look at the qualifier and let's build the solution from the ground up. First thing I've done here is I've taken the demo input, the example input from the documentation, and I've prepared it here so we can have something to work on as we go along. So you might, the first thing you might notice here is this make table function. That function is given in the template, and that's the function you expect it to have. If you're new to Python, some things here might not make sense. For example, what are these things here after the arguments, after your parameters? what's happening here between the function definition and our code here. I'm gonna go over all of that now. So the first part is just these are your parameters. These are typing annotations, which basically tell anybody that sees your program, and it tells other programs such as your code editor what the function expects. So for example, the first function here is just expecting the first argument is rows, which is a list of anything, and labels is an optional list of anything, which means it can be none, and centered is a boolean, so true or false. And finally, the last part here is just that it returns a string. And to move on, this part here is called the docstring. If you're not familiar, there are many styles of docstrings. These are just documentation for your functions, so people using them and seeing them can know what you expect. This specific style is called restructured text, or REST, which is mainly used by a documentation generator called Sphinx. All right. This format just specifies what your parameters are. So rows, labels, and centered, like we went over, their definition, so what they should be, or what or details about them, or anything important to note. And finally, what your function returns. In this case, it's a table representing the rows passed in, like the documentation specified. So with all of that out of the way, we can now finally start talking about making an actual solution. So the first thing to go over here, let me just see if there are any questions so far. Yep, this is just all vanilla Python, nothing here that you can't do with any library without any libraries or whatever. All right. All right. So let's start making the actual solution. I'm gonna be creating my solution from the ground up, and it's gonna be based on the final solution that we're gonna be sharing after the stream. So first things first. How do we approach this problem? We are given some data. We're told to turn it into a table. So let's look at our table, and let's look at some sample data to see what we should expect. The first example here is nice and convenient because it's short and it contains the least amount of things needed to make our program. First, we're told that our rows are going to be a list of lists. Each list is going to contain the values for that row, and we're told we should have to print them all padded correctly so they're all aligned with a border around the edge to make a table. The second example also tells us that the types can be of the rows can be of any type, whether that be strings, integers, floats, negative numbers, anything that you can imagine, I guess. And finally, we're told about labels, but we can get into that in a bit. One important thing to note here is the requirements specify that the input can be anything that can be has a string representation. Basically, if you can call string on it and get a logical value, then it's valid for our code. So let's start here. First things, we know that our output is expecting strings, and we're told that all of the things we're given can be turned into strings. But we've given them as any, which means they can be any type. So the first thing I would do here is I'd make sure they're all strings so we can use them and work with them easier as we move on. So let's first just make a function to turn things into a string. And how do you turn something into a string? Well, you call the string method on it. So I'm gonna have a function called parse row, which takes a row and converts it into a string. Now the row can be of just a list of anything, so specify that as a list of any, and it's gonna return a list of string. We're just following we're just following the same format that we did here for the typing annotations. Now here's one useful tool that because I have a list and I want to perform a function on it for each item in the list, I'm gonna use something called map. Map is a built-in function which takes two arguments. The first is a function. In our case, that's string. A function is something that you can just call like so. That's a function. And the second argument is a list that you can perform this argument, this operation on. Um, what I've done here is I've called string on every argument of row. Now the reason I'm going over this is because you're going to see map a lot in the official solution, so it's good to get yourself familiar with it now. Moving on from here, before we can move on, you might see that my IDE is complaining right now because I said that my function returns a list of string, yet it's returning this. And what map returns is a generator. A generator is something that you can go over. So for example, for x in range whatever, that's a generator. If you want to turn it into a list, you can call list on it like so. This is another function which takes an iterable such as a generator and makes it into a list. Now I've done a lot of talking, so let's move on to calling the parser function on our rows to make everything into a string. So rows equals, I'm going to use parse. I'm going to use map again here because we're given a list of lists, and the parser function expects just one list. Note here how I'm passing the function name, not calling the function. If I call the function, that would do something different because it passed the result of the function, not the function itself. And now let's just see what happens when we do this. I have to call list on the map here again. Now, as you can see, what happened here is that I messed up a little bit in the unpacking. What unpacking is the star notation here that I've been using for quite a while. What it does is it takes a list and it unpacks it into multiple arguments. Since we're using map here on a single flat list, we just want to call it without unpacking it. Same here, because we're also just passing the rows one by one, all of the rows one by one by calling map. We don't want to unpack them yet. If I print this again, and I messed up. What am I missing here? Oh, no, right. We do want to unpack this the rows value here because it's a 2D list, and we want to call it on just the list. I feel like I'm missing something here. So I'm sure someone's gonna tell me in the comments in a second. Well, this is just what happens when you code live, I guess. All right, I'm gonna give me a second to debug this. Switch back to the code. All right. What I also forgot here is I had to remove the star from here. I guess I'm gonna talk about stars more when I get to them, but for now, just focus on what we have. So what I've done here is I've made sure that whatever arguments I pass in have been converted into a string before we start using them. If we want to test them, we should probably pass other non-string values into these lists and see what happens. We can see now that I passed in a list of lemon as a string and one as an integer, and I got back a list of lemon as a string and one as a string. Now let's move on to the next step. Now that we got that out of the way, the next part I want to focus on is, well, first, we are given rows, but to find to align the values in the table, you'd want to know how wide each column is, so you can use the alignment tools that we went over earlier using print and whatnot. To do that, we should first uh, convert from rows over to columns. Now, how could you go about doing that? Well, a column is the is each value from a row for a given index. So the first column is the first value of each list inside our rows. So if I do something like for row in rows, and gonna create a new list we can store our columns in. For row and rows, we wanna let me just do this first. For first to find out how many items are in each column, we can items column size. We can just look, since we're told all the rows are going to be of the same size, we can look at how many items are in each row. So for example, if we look at the number of items in row 0, that's the column size. So for what I'm doing here is I'm looking at for example, I'm looking at column 0 using the 4-column index and range. I'm gonna look at each row, and I'm gonna take column number 0 from each row. So for example, row column index, that's gonna give for the first row, that's gonna give us the first what am I missing here? That's gonna give us the first item in the first row, and then we move on to the first item in the second row, and so on. Now that's what a column is. So gonna add all of that to a list, and then finally add each row. Gonna add what we found for each row to the larger column list. Now, if we just print what we just did, things don't crash. We should see that it crashed. You should see now that I've taken the first item from each of these rows, so the names here, and I've put them into a list. And I've taken the second item from each of these rows, the numbers, and put them into another list. Now we have columns, and we can start looking at things such as getting the width of each column and doing padding. Now, how do we get? Now I'm going to show you how the official solution does this. It's a little different. Yeah, it just does this. Which this goes over a few things that we haven't used yet, we haven't seen, such as zip. That's a really useful tool for working with lists and other iterables that you should probably look at, but I'm not going to be covering it just yet. Now back to our code here. Next part is, now that we have all our columns separated, let's work on getting the maximum length of each column. Now to find that, we just want to find the highest length item in each list. So for column and columns, I'm gonna keep a list of width here as we go along. Item. What I've done here is I'm going over every item in every column, and I'm saying if the length of this item, remember we converted it to string, so that's going to give us, we convert all items to string, so that's going to give us how many letters are in that string. If that is greater than the current max width, save that as the new max width, and do that for all the values in all our columns until we get the max width in this column, and then save that to the width list. Let's just print this to make sure we got that right. As I write this in, this is a good thing to mention now. When you're working with code, it's a good idea to have a short feedback cycle. So as you write a new piece of code, test it, make sure it works, and then move on. That makes debugging easier instead of having mistakes you don't see and having to go back and solve them and figure out where they are. So let's test this now. You can see here that in the first list, the longest value I think is Sebastian here, which should be 10 characters. I'm not gonna count them. I'm gonna have my program count them up. They're 10 characters. And since that's the longest value in the list, we got that as our max width. For the second one, all of these values have just one character, so the max width here is 1. Now, I'm convinced that we've got this right. We can move on to the next part. So now, if you cast your mind back a few minutes, we said we're doing this so we can find the max width, so we can find the padding needed for each character, so we can then use the print to format them as needed. So let's do that now. Added columns. Now here's how I'm gonna do this. First is before let's look at the table, the examples real quick. What we see here is we've got the first separator here, which is a pipe. Then we've got one space, and then we've got the value followed by enough spaces such that the spaces here are going to be equal to the one space after the longest character, and then followed by another pipe to close it all off. That way we get a nice round table. For now, I'm just going to focus on doing this middle part. I'm not going to worry about the top or the bottom. We're just going to focus about getting this working. I'm also going to go back down to one column to make this easier here. I just hit the mic, sorry about that. So the like we just saw, we're gonna be using this pipe operator here, followed by the value. Now, if you cast your mind back a little bit, there's one space before and after. If you cast your mind back a little bit, you can remember that we talked about having the string formatters and how you can do something like this to get it center aligned, or something like this to get it left aligned, right aligned, and so on. Now, if we go back to the function definition here, we also notice that whether it's centered or left aligned is going to be based on this Boolean. So let's test that here. If centered, we want to record this using the centering operator here. Otherwise, we want to use the left align operator or formatter. Now let's see what that did. First thing I'm gonna notice is it made a bit of a mess. I want to say a bit, I mean a real mess. We're not formatting our print yet to look like it should in the table, but we can see that all the values seem to have one and one before. What did I miss? I missed something. Right, the column size, I forgot to define it. Now we found the width here. We just want to use them here. I'm not sure why I missed that. All right. The width of each column is going to be based on the index of the column because we stored in a list. This is where something like enumerate is going to come in handy. Enumerate, if you've never heard of it, it takes an iterable and it gives you an index plus the value. It's like doing a for item in range and then or for value in range and then using that value on a list. This is easier to demonstrate if I just so here it's giving me the index of the column in our columns list, which in this case is going to be 0 because there's only one column. And it's going to give me the value of the column, which is this list itself. We can use that to access the index of our width. Now it made a real mess, but we can see that for shorter names there's a lot of space after them and one space before them. For the longest name, there's only one space before and after, and that seems to be the case for all of these values. So that seems about what we'd expect from the example. Shortest name has a bunch of space after it. Longest name has just one space after it. Oh boy. Okay. Moving on from there, let's look at printing them like a table, so they look like a table. So how would we go about that? Well, this is just a list of strings. So let's go over them. Value in column. Now we're getting a lot closer to something like what we have in the what we have in the documentation in the README. That shows that we've got them all properly aligned, and now we're ready to tackle more complex concepts such as multiple columns and titles and having the space the closing box on top and below. But for now, we've made pretty good progress so far, minus all the hiccups. This is a good time to check back in with our official solution to see how things are going different and what's happening here. Now, you might see that all we've done so far is this part right here. The solution has done it a lot shorter than us, which is nice. I'm seeing Salt Die, one of our most prolific TUI experts, commenting on using zip here, and that's one of the things that our solution does. Like I said, you're gonna notice that there's a lot of using the usage of map and enumerate to do basically what we've been doing. So first, let's go from the top. The first thing they did is also convert from rows to columns using this function here, which this should be pretty understandable if we minus one thing right here, which is the unpacking star. And like we said, having it in the function definition means you can pass as many arguments as you want and it pack them all into one list. And here's gonna unpack them all. What zip does is it takes multiple iterables. You can see that's the documentation for zip. It takes multiple iterables or multiple lists in this case, and it takes the first item of each list and pairs them together. So it takes the first item of the first list, first item of the second list, first item of the third list, and returns them all together. Or it takes the second item of the second list, second item of the first list, second item of the second list, second item of the third list, and pairs them all together, and so on and so forth. How that applies to our solution here is it takes the first value of each row and puts them into a list. Takes the second value of each row and puts them into a list. That way we get our columns. Finally, it just since zip returns a generator like we talked about before, we call list on it to make sure that this returns a list. And finally, we call list on the map, so we get a list. And this is what we've done in the first part of our solution. This part up here. Going back to it, next part is what we're doing now, which is finding the padding. The first thing is finding the column width, which was done here using length and mapping the length function onto each value in the column. You'll notice there's another part here which casts it to a string first. We've already done that at the very beginning with all our values, so we don't need to do it here again. If this was our solution, just directly call it like so. But ultimately, it finds out width and it does the enumerate trick here again, like we've done. Again, converting to string, but we've already done that. And now we're gonna see something here that you might have not seen before, which is a ternary. This is something they're gonna find in pretty much all programming languages. It's an inline if function. So what the ternary does is it has here we're trying to get a value out of it. So we say value 1. This is if a condition here is true, so it's going to return that value. So if true, else should return another value. If the condition here was not true, if it was something else such as false, then this would be it would not return. It would return what we have on the right instead of what we have on the left. So what we have after the else. What this means here is it looks if centered is true, then it uses the center operator, and if it's not true, if it's false, it uses the left align operator. And that's now we're basically caught up with the official solution. You also notice here that they did the same thing with having spaces, but they didn't use the pipe operator yet. That's for a reason we're going to get into in a bit. It has to do with their solution and how they solved it. But most importantly, now we want to see how can we do what we just did, but with more columns and more values. So let's add back in the other column. Right. But I've added the other column, and let's see what our program does. Nothing, because it didn't print anything. Now, our first column seems unchanged. I'm not seeing anything different here. Our second column, well, that's a bit of a different story. It's done everything like we wanted it to. It's got the right padding. It's got one and one after, one before and one after on all of the values, and I'm not seeing any problems with it. So we can see that our solution so far works with a single column or multiple columns. So we're ready to move on to aligning all the columns and printing them one on top of the other. So here's pretty simple so far, because when we had just one column, it was easy. You just go through the column, go through the values in the column, and print them one on top of the other. But here, because we have multiple columns, the first value from the first column is going to be printed, followed by the first value of the second column. So we basically just want to go back to rows again, so we can print them from left to right, now that we've got the padding done. So how can we switch back to rows? Well, we just have to reverse what we did up here. Now I'm going to save some time here and just do what the official solution did. It's going to be easier to copy it than do it off memory. This is pretty much exactly what we've done, just compacted down a lot. Just make sure. Now we've once again went back to name and integer for each list. Now let's see how that would look like if we printed it all. So for rows, one thing I've done earlier here is I added in the separators beforehand, which leaves us with this situation where we have a separator before and after the value, which is going to be annoying to deal with, so I'm just gonna remove them and I'm gonna add them in manually here as we join, which is gonna allow us to introduce one neat trick here. Uh, Now, if you're working with lists a lot, one thing that you might find useful in combining the values of a list is join. Now, join is a function you can use on a string. It takes whatever the value is in the string, and it uses whatever it uses it to combine each item in the iterable. So, for example, the first item here is going to be lemon, and the second item in the iterable is going to be one. So it's going to print lemon and one joined by by the pipe operator here. So let's try that. We're gonna lose the pipe operator before and after it, but we can add that in ourselves afterwards. But what we see here is that we're now getting even closer to a final solution because we're getting multiple columns printed. If we wanted to just add in the pipe operator before and after, we can do that here. Basically what I've done is I've taken what we had, which was printing this down here, and I've surrounded it with other pipes, and now we can do this and see that we're getting very close to what looks like a table. The next part we want to deal with is, if we just have a look at our README again. Well, it's not rendering, that's great. But we'll see that here you're also meant to be able to take labels, and if a label is given, you should print it on top of the table with this separator and this separator here. Well, the first part is easy. We can print them without the separators. We just have to add them to the columns at the very beginning. First, let's convert to strings like we. Is this? Yeah. Let's convert to strings like we were doing here. Since labels can be none, we should probably check that first, since it's an optional argument. Now, if we pass labels, they're gonna be strings. Next part is just the next part we have here is we wanna, when we're doing the column measurement, we want to make sure we have it here so we can find the correct width with the item. And to do that, we can just for row and rows, I'm gonna join both the labels and the rows into a single list here that we can go over. Right, and I forgot to check if it's done. I'm gonna use the labels from the example here. If we test that, and I didn't print anything, so test that, all our code so far should be able to just handle it as is, minus the fact that no, it should all be able to handle it as is. I should not unpack it here since it's, right. So what I've done here is I've said if you have labels, then put them in a list, as well as unpack rows into the same list. So so now it's basically this list right here with the label list on top of it. Now let me also copy the rows from the example. We should see each item from the labels lines up with one column from our list. Um, let's check back in with the official solution here. We can see that the official solution did something somewhat similar here by it basically did not convert it into columns like we did, but it did consider it. Uh, it did consider it into the columns up here, and so it got to it before we did. All right, now back to the solution. Now that we've got basically everything in order, the next part here is just going to be uh, printing the closing borders on top and below the um, the table, and to print separating the boundary between the labels and the values of the table. So now to start here, let's just look at how we close off the table, which are these three characters. These three characters are going to be uh, these three characters are going to be used to get first the corners, top right and top left corners here, as well as this, which separates each column at the top. Between each of these three characters, we're expected to use one or more of these horizontal lines to separate them into the right size for each column. So to get started here, let's first jump back into when we were doing the column width and when we were converting columns back into rows. What I'm going to want to do here is I'm going to want to add the separation based on the column width, which means I have to once again go through each of the column width and let's just define our border as a string. Copy in the first character. Now I'm gonna want to add as many horizontal lines as there are width. So for so just gonna copy the character. Now we want to add it as much as needed for each item, and then after that we close it off. Close each column off with one of these, which just separates the columns, and then finally at the very end, let's just print what we have now. Top border. We have something that looks a bit like this. If we print the rows under it, we can see that I did not properly align it. What am I missing? Oh boy. Uh, da, 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 da. Why are they not the same size? Gotta figure that out now. Something padding. Oh, right. Thank you. So what I've missed is there's one space before and after the values. So just add due to the width. Now they are finally properly aligned. Of course, with the exception that the top right corner is not yet prepared and it's just using the middle separator. We can fix that by removing the last character from that string and using a corner piece instead. What I've done here is I've taken all the characters except the last one, and I'm just gonna add in the corner piece. Now, if you print the top border again, it should hopefully line up with our table. Now I'm gonna be honest. The official solution had a much cleaner approach to this, and a much more modular one. I'm gonna show it off here in a second. Um, this is the whole thing. So it also got around the problem of adding the two extra characters by measuring the actual column itself, which we didn't do, but that's a very much valid approach to it. Now let's go back to it. It also had a modular approach to adding in the corners for each piece, but I'm gonna talk about that in a second. Now, what you see here is I'm doing a lot of just adding in these pieces manually and then adding in the content manually. So I'm gonna do basically what the official solution did as well, which it made a function to help format the values using the borders. Uh, Now, if we look at this at the print here, we can see that there are three fundamental parts: the left part, the right part, and the middle part. In this case, for the row itself, it's just they're all 35 characters. But for something like top, it's a left corner, right corner, and the horizontal piece. So what I'm gonna do is I'm gonna accept three different parts: one left, one right, and one middle. I'm gonna use that in order to join all the values, and in order to build our table in an easier way. So um, this type of annotation is for a tuple. If you've never heard of tuples, they are somewhat similar to lists in that they contain multiple values, but a tuple can have is not mutable, and it can also have a rigid structure like this with just three values as we've defined here, and the actual row itself, which is list of string and a single string. What I want to do now is I want to basically do what this print statement down here was doing in joining the joining the leftmost operator, the middle operator, and the right operator into one string. Now, one cool trick which the solution uses is tuple unpacking, which that's what I'm doing here. You can take a tuple and you can break it down into its parts. Since I know that this tuple has just three components, it's easy enough to break it down into left, middle, and right using tuple unpacking. Now, the left here is going to use left, the right is going to use right, center is going to use center, combined with it's going to join the row like we were doing. Now, if we go ahead and have a look at this, we've got to first define the row, which is just this part here. And do the same here for our actual rows. Just that's what rows is already. And now we can do something like print format row. The separators for the first, I'm gonna print the top portion. followed by I'm gonna pass it the row, and if you have a look at that, okay, what did I miss? Oh right. What I missed is we probably don't want to do this. We just want to. Yeah, how did the solution do this? I remember the solution did it in a clever way as well for this. Right. Uh, hmm. Okay. All right. Not to worry about that for now. I'm just gonna keep the solution for this as it was because probably don't have time to figure this out right now. I'll get back to that in a second. The middle row should pretty much just be what we already had. That should work hopefully because it's what we already had. Now it's missing. We'll get back to that in a second. Just the rows. Feels like I've definitely messed something up here. Right, I know what I missed. I should only pass in one row at a time, so I'm just gonna call map on that. And it's working again, somehow. I'm not sure what I just changed. Well, I don't think I've changed anything. Right, well, I guess it did work as expected. I just must have mistyped something. Anyways, I'm gonna pretend that that worked exactly like I wanted it to. Let's also duplicate this for the bottom row. The bottom row is the exact same. It's just using flip pieces instead of what we had. And we are almost there for the official solution to the problem. We're just missing the part between the separator between the labels and the values. Now, if you haven't noticed, it's pretty similar when it comes to the separators we've already been doing. It's just using slightly different pieces, and we have to insert them in a different order. Um, so let's just get it working first, and then we can worry about these three pieces here. We can worry about inserting them in the right position once we've added in the pieces. Now, if this line was in the right position, it should have the correct format. So let's insert it into our position by the easiest way to do it right here would just be to manually do the labels row if there is one. If labels have a labels row, then print that row alone. if we have labels, that would be in the first row, because of what we did earlier. Um, Rows here. And here we're not going to want to go over all the rows because we've just covered it, covered that part using we just covered the first row using this here. So what I'm going to do is, if we have labels, that start from the first row. Otherwise, we're going to want to do all the rows. Now, if we print that, we are more or less there. The only thing remaining now is, if we go back to the documentation, it talked about not having any prints or any debug statements. We're expected to return the table as a return value instead of printing it. So what I'm gonna do here is, since basically everything above this part was formatting and this part was printing, I'm gonna go and combine all these into a list first. So table. For each thing we've been printing, I'm gonna add it to a list. And then I'm going to, since now we have each row as a separate entry in the list, we're gonna join them all using line breaks, which is basically what the print was doing. Because we're not actually gonna output it anywhere. We're just gonna use join again to combine them into one table. And finally, if we return that value, we should now be done with this solution. Let's just print the return value of the function here to make sure. And it seems everything still works. Now let's try a few of the examples to make sure we've got everything right. This one is centered, which we tested, but so everything seems to have worked as expected. Now, what we usually do for these code jams is we provide a bunch of unit tests to test your program to make sure you pass. This is the one that was provided. I'm gonna run it on my program and make sure that everything works as expected. And as we can see, we passed all the tests here. If I'm using PyCharm here, which has its own test runner, but if you are not using PyCharm, if you're using something else, I'm just gonna go over how you do it in a terminal using me testing it earlier. Python. We're gonna use the unit test module, which is a part of the standard library, and we're gonna give it the name of our test suite, which is test.py. And now, if it, you can see that it says run all our tests and everything turned out okay, and then we're good. If something had failed, for example, if we forgot to convert the strings first, I can show. We can just quickly go over how that would look like, how a failure would look like, and how we can work on debugging failures. This part here is the one that was converting to strings. So let's test that. You can see that we've now got a bunch of errors, which is ironically the first time we actually want errors today. You can see how it looks like when you fail using a terminal. But we can now get to the next most important part of developing something like this, which is figuring out if you made a mistake and how to go about fixing it. This is my IDE neatly formats something like this. So it's actually readable. It's displayed by tests. But if you're on a terminal, you get the same output. It just look a lot more like this. Now, if I just take a look at what failed, I can click here. It's going to take me to the test. You can see the file and where it's going to take you, and the test name. And we can also see the error itself. First thing I'm doing here is I'm studying the input to get an idea of what was different between my tests and what the tests and what the failing tests did. So first thing we can see is it passed in numbers, which, as we said, we're no longer converting them to strings, so that's going to fail. And we can look at where it failed in our code, which was trying to convert calling length here. It says it called length on an int. So that's going to give us a hint that we were expecting a string, but we got an int. Why is that, and how could we work on fixing it? And that's what this part here was for. Anyways, that's more or less what we had to cover for the live stream. But we also just have to go quickly over the solution. It's a pretty clean solution. You're gonna notice elements of it here that we've also had. You're gonna notice some things that are quite a bit different, like for example the transposing here, and but it's definitely a good idea to go over this and see how things are different between your solution and this solution, or my solution and this solution, and you can see quite a few good practices for coding in Python. I'm gonna link this in chat now. Uh, this was worked on by a lot of staff and contributors in the Python Discord organization. But you can see, you can go over it yourself when you have time. And before we finish off, I'd just like to go over a few more things. First is this fun solution here. Now, if you probably can't see it because it's not very big, but this is the entire solution. Nearly a one-liner. It was made by our very own HSP over in the Python staff. I wouldn't recommend coding like this if you want your teammates to stay sane, but it's an interesting difference nonetheless. I'm gonna post that in chat in a second as well. And finally, before we close off, I want to talk about some of the things that you could do to test yourself or improve your skills while you wait for the theme announcement. I'm gonna go over what our initial qualifier looked like and what has changed since then. So there are quite a few requirements that have changed. Initially, there was we expected you to have a title cell. So at the very top of your table, a cell that goes the entire width of the table, that can contain a title. An optional minimum width for the columns. So the user could specify that each column must at least be 5 characters wide, for example. This one's is a bit less complicated. Right alignment on top of the left and central alignment we already have. And finally, different table outlines. So what this means is we might have asked you to accept different borders or different shapes for the outline. For example, here we specified very rigid requirements for left, right, and middle, but you could challenge yourself to see if you could accept any input for this. Other than that, if no one has any questions, we should be. If you've got any questions, now is the time to ask them. I'm not seeing anything, so I'm going to close this off by mentioning. I'm getting a question. Yeah, I'm gonna post all the files I've covered, my solution, the official solution, and the one-liner. I'm gonna post them all in on Discord after I'm done, and the live stream is gonna be available after the fact on YouTube, so you can. Yeah, it's gonna be available on YouTube if you want to rewatch it after it. But that's all for now, and thank you for watching.